Okay, one more short video because I didn't realize I had a couple more slides that I wanted to go over that I could have folded into the last lesson. I wanted to go to some approaches for making pseudocode or flowchart, and to coding in general. So not only will you be using pseudocode to help you design your code, but how you approach coding, how you approach thinking through the problem. There's a couple of things to keep in mind. One of them being modularization. What I don't want is I don't want to have to redo the same thing over and over and over and over again. What I want is, and have this giant behemoth of a problem. If you've ever done one of those really complicated Legos, you'll get little booklets, one for each part of the Lego that you're building, and then you put them all together. Right? If you're looking at modules that you're reading, or chapters in a book, or if instructions for setting up a barbecue, anything that has any level of complexity, you normally have a lot of instructions, and they break it down into little subparts, so that you can do one chunk at a time. And those modules can then be applied in other places. It also makes it less intimidating and less overwhelming. Um, and so what we want is modular data so that we can also reuse our data. So if I have one module like paying for the cashier, or maybe find the minimum in a list of numbers, I can keep on reusing that one function or that one module over and over and over again, not have to put that same pseudocode or that same code in a bunch of different places. I want to write it once, write it correctly, and just reuse it everywhere. It also breaks down the monotony, or the amount of code I have. Um, and we also have to deal with random data. We don't necessarily know what the data is going to look like. We may have a list of 5 numbers, we may have a list of 4 billion numbers. A modular code allows you to abstract away things so you can just deal with it. You can group your data into related, hierarchically group your data in related groups and put in related items. Organizing and arranging your code and your approaches helps you make sense of things. When things get really out of hand, it's really easy for the problem to get well out of hand, too complex for anyone to actually understand. Organization and making sure you keep modular code is the only way we have to make it comprehensible. All right. Step number 2 for when you're writing code, as a piece of advice, is stepwise refinement. Start with something vague. Start with something general. Determine the class average of so the top level idea is determine the class average for a quiz. Our first step is, how do I do this? Oh, well, I initialize my variables, I input, I get the input from the user, I add it to the total, and then I get the total count. I calculate the average and I print it out. Well, that's fine, right? Those are 3 steps. That's actually how I would do an average. I get the input, I'd add it up to some total count in there, and then I divide it by the number of items I added and print out the value. But what I really should be doing is refining it even more. I initialize this variable to 0. I initialize counter to 0. I get the input for the first grade. I have a while loop. I add that value to the sum, right? And keep doing this. What I want is multiple passes at making it better and better and better. Now, you don't have to spend hours and hours on your pseudocode, but as you iteratively do it, when you get to the point of, like, I know exactly how to do this step, this step, this step, this step, and this step, that's when you stop doing your pseudocode and you can start coding. When there's no ambiguity on how you're going to be going about the problem, that's how far you need to go with the pseudocode, right? It's not add 2 numbers together. Add 2 numbers together, I do X, Y, and Z, like I need to do this. You don't need to break that down that much. But finding the smallest value in a list, maybe that you need some pseudocode for that. Or finding the second largest value in the list, which, speaking of which, that's what our thing is going to be looking at. And you can even go further than that, by the way. Another refinement. We kept steps 1 and 2 the exact same. Step 3 is a bit too vague, right? Set the average equal to the sum divided by the counter. Okay, well, if the count is not 0, then we set the average total divided by the count, and then we print the average. Otherwise, we print no grades were entered, right? We have another condition if you didn't pass me any grades. That is a perfectly valid input, and we need to handle those cases. And you only get to realizing that, this weird edge case, when you've broken the problem into small enough chunks that you actually realize what the problem is. All right, so here's our take-home exercise before I get to doing a lab video. I want you to be looking at how you would find the five smallest values in a list of numbers. We don't know how big the list is, just say it as n numbers or list size worth of numbers. I want you to find the five smallest values. What if all the values are the same? What if the numbers are negative? What if the numbers are positive? What if they're fractions? What, like, you don't know. How can we do it efficiently? And how do we figure out taking the smallest n values, not five, but n of the smallest values in a list, right? Can we? Can you think about it in a methodical way? That's actually a challenge, by the way, in case you're wondering. That's actually, I would say that's a very, very difficult task to do. I want you to think about it long and hard before you actually try to write your pseudocode. If I asked you to write this in code, you definitely need to be writing pseudocode for it. And I'll have people trying not to use pseudocode. Like, no, you have to think it through before you actually start implementing. So give that a try, either a flowchart or some pseudocode, just for additional practice. When we come back next time, we'll be looking at programming in Scratch. Thanks, everyone.